A very good evening to all of you. The topic of our presentation is the importance of predictive maintenance in industrial settings, and our focus is on the emerging technologies and analytics. Myself, Tarun Agrawal, I am posted at Uran plant. I joined ONGC in 2018, working there in C2C3 plant, looking after the operations and the maintenance parts of the safety control system and the process control system. In addition to that, I am also involved in the two digital initiatives of DCOE. One of being is the DSV project, and the second one is the predictive maintenance for rotating gas compressors in Uran plant. This tender is currently undergoing, and maybe this month we would be in a position to award the contract. The agenda of our presentation is like this. We would be telling about why there is a need of the predictive maintenance. What are the key technologies which have emerged over the past few years, and some use case studies. What are all the challenges and how we can overcome those challenges? What are the way forward in this technology? In the end, some conclusions and Q&A for the audience. What is predictive maintenance? Everybody talks about this word predictive maintenance. What does it mean? It basically means telling something beforehand. In the sense, if there is an equipment which is going to fail, everybody knows that every mechanical component has some life and it will fail. But can you predict that failure of an equipment beforehand, so that an action can be taken and planning can be carried out meticulously? That's where the predictive maintenance comes into the picture. What are the key benefits associated with it? So once you have the proper planning and scheduling, then it definitely improves your cost. It gives the flexibility for operation. It enhances the reliability. It improves the safety. So over the period of time, all maintenance strategies have evolved. Earlier, it used to be the reactive maintenance, in which operator used to take an action based upon the breakdown of the machine. Suppose something has gone bad or an equipment is under failure, that equipment can be brought into the umbrella, can be fixed based upon the write-up, based upon the parts availability, or when the equipment is actually failed, then only we take the necessary action. That is reactive maintenance. Then comes the part of time-based maintenance or preventive maintenance. That's what we are generally doing in ONGC. It basically talks about our past experience and mainly guided by the OEMs running our condition. Now the thing has come for the predictive maintenance. The predictive maintenance is nothing but predictive maintenance, upgraded version of predictive maintenance. And further, the future is prescriptive maintenance, and again the way forward is the autonomous maintenance. Now, what are the challenges in the traditional maintenance? If we very well can recall that you have an unplanned shutdown, you have a target to achieve, but somehow your critical equipment is down, then definitely your operation efficiency will down, your production loss will occur, and something and if you don't have the spare parts available with you, then it is also a big challenge. In addition to that, if there are no resources available with you, your skilled manpower is not available, your OEM support is not available, then also it is a big headache. Also, you are dependent upon the machine for your production requirement rather than being the other way around. If you know that you can figure out that equipment can run up to so much hours more beyond the OEM recommendation, then it is can be a use case study for us. We can bring more value out of it, and also our operations and turnarounds can be more flexibly planned. In all these contexts, the scenario of predictive maintenance can revolutionize the way we do the maintenance. What are all the key benefits which can be derived out of the predictive maintenance? Is it helps us in the reduction of the downtime. It gives you an indication, an early warning sign that an equipment or a component of an equipment is going to fail. Moreover, it is not necessary to do overhauling just based upon the OEM recommendation. It may be, there are chances that for the critical equipment you can plan your overhaul maybe up to few more running hours other than the OEM recommendation, which will increase in their cost savings and will also give you a freedom to work. So that's how this predictive maintenance can be a game changer. When we talk about the reactive maintenance, preventive maintenance and predictive maintenance, the early mindset of maintenance used to be the reactive maintenance where the breakdown occurs. Next comes the preventive maintenance, when the maintenance activities are beyond the conventional way of doing the maintenance based upon the OEM's running hours and overhauling of the critical equipments. Now the next thing is the predictive maintenance. Predictive maintenance will tell you how much is the remaining useful life of a component or an equipment. Based upon the data it will work upon, it will be a game changer to give you a data driven decision in a much larger context. When we talk about the what are all the key components of predictive maintenance, so there are basically 4-5 steps. The very first steps is the sensors and the IoT devices. You cannot predict something if you don't measure it, so you need to have the sensor associated with it so that you can measure the device, measure the physical process parameter such as pressure, temperature, flow, vibration, humidity or XYZ things. And the next part comes to capture that data into a gateway to a cloud environment or to a centralized server. The second one is the data collection. So the data collection needs to be done depending upon the requirement. Maybe it can be processed. So now the sensors have come which can give you a refresh rate of up to 1 second, extending upon to 1 minute also. The next big thing is the data processing. So with the advancement of the computing technologies and the machine learnings and artificial intelligence, data processing can be done at a much higher speed than ever before. Everybody is aware about the ChatGPT and this Microsoft Copilot. So now there is a war, like if somebody has use ChatGPT in the earlier phase, they might be they might can appreciate the fact that earlier the response of the large language model was very slow compared to the models which we are using. So even the 3.5 version which we used at the launch of the ChatGPT was giving a very slower response compared to the same model which we are using now. So the data processing capabilities have enhanced manifold. So thanks to machine learning and artificial intelligence. Now the next things Now the next thing is the predictive algorithms. With the new change in the era, the predictive algorithms have also evolved, be it the supervised learning or the unsupervised learning or the machine learning or the deep learning. These things have evolved a lot over the period of time. Now comes the what are the various technologies which are emerging. First one is the Internet of Things. Internet of Things simply means that uh, your field devices, your field sensors are very much smart. They can operate in the low power environment with high efficiency, as well as they can cater to they are able to reproduce the data in a much faster way, and they are compact in size. Second one is the artificial intelligence and the machine learning. Both the things are said interchangeably, however there is a minute difference between the two. Machine learning is a subset of artificial intelligence, while deep learning is a subset of machine learning. Now comes the big data analytics. It is basically how to handle the huge amount of data in a structured way. Having a data here and there and not using it to the fully is again a bad practice or something to work upon. Now comes the digital twins. How can digital twins be brought into this environment is something. Digital twins is nothing but the physical, statistical or a mathematical replica of your physical asset. The idea behind is to have a digital twin is to have the look and feel or of your physical asset. It works upon the fundamental that it can be directly associated with your say you have a distillation column or in a process complex, or maybe a heater treater. So how does your heater treater works in a particular fashion? It depends upon the way you model it in a mathematical way. So at what particular pressure and temperature your model is going to behave, the same can be brought out using this digital twins. So what is this IIoT? When industrial Internet of Things is a new concept which comes along with the Industry 4.0. It talks about the real-time monitoring of all the process environment or equipment using the sensors. Sensors can be mounted directly or remotely, and it can be wired as well as wireless. What are all the roles in the predictive maintenance? What are all the types of sensors that are available? As of now, temperature, pressure, flow and vibration can be sensed using these IoT sensors. It works upon the data collection and the monitoring. So the challenge here is to have the remote monitoring of the data as well as the real-time data on a continuous basis and at any point of location, from remote location also. How AI and machine learning analyze data patterns? It depends upon how good your model is or how trained your model is. The more data you fetch into the model, the more it will be capable enough to predict the fault. So there is a set of data, there is a statistical model, there is a historical data. The historical data contains all the conditions of, say, startup, shutdown, or any fluctuations. So the model is being trained based upon the data available at the back end. So the model will tune itself while it is getting learned over and over the period of time, which will help the model to predict the failure in advance. Once your model is fully learned, then next round of activities can be carried upon. Now comes the picture of big data analytics. Everybody has heard of this big data analytics and the blockchain technologies. So the big data, when you have this huge data, there comes the problem of storing the data and maintaining the data in a structured format, in a well defined format, so that it can be processed further. This processing of the data, large data, is done through the big data analytics. Here comes the new, everybody has heard of the word data scientist or data mining engineer. So those engineers and scientists are capable of analyzing the whole set of data using their specially designed algorithms, which can give us a final output. So there are, in the background, there is whole set of churning which takes place. And we can talk about the data quality. The greater the data quality is, the best you can manage this whole show. It is basically virtual models of the physical assets, and there are very much use case applications of the digital twins. So HYSYS is one of the example of digital twins for the process plant. The actual disturbance in a process plant is being done before the before the simulation of the process in the HYSYS. How we get the output is one challenge that can be tuned to the physical assets. Another one is the augmented reality and virtual reality. So this ER VR sets is also a very common thing, and nowadays everybody talks about those wearables which once you go near to the equipment, you are able to see the manual and what are all the past use cases available with it. Now let's talk about this one case study of predictive maintenance in the context of ONGC. So at Uran plant, on a pilot basis under the initiative of digital initiative, it was decided to do a predictive maintenance. So idea behind predictive maintenance is to have the feel how it would work. So what we have decided is the main challenge here is the data. So we are already having this process data available in the DCS, and our machine data is available in the system one. So what we have done is we have collected this whole data. What we have proposed is we would be collecting this whole data in a simple historian. This historian will be having the data, process data, as well as the machine data. So the process data, when you talk about the process data, it comprises of suction pressure, suction temperature, suction flow, discharge pressure, discharge temperature, discharge flow, and in any other intermediate stage temperature, pressure and flow. It's lube oil parameters, seal oil parameters, lube oil temperature, seal oil temperature, like that. So these process parameters, they when the data is interpreted along with the machine data, such as vibration at the gearbox end, at the non-drive end of the compressor, at the drive end of the motor, bearing temperature, it gives us a wholesome view of the physical asset. So that whole data is being captured in a process historian. That process historian will then transfer the data to a predictive maintenance server. That server will be nothing but it would be capturing the uh, whole set of machine data and process data, and it will be developed. An algorithm would be run, that is machine learning and AI based learning algorithms would be run, and the model, statistical and physics based model, would be prepared. Based upon that, there would be certain key learnings. If it is available in the system, then the model will be trained on this whole large set of data, and also upon the design condition, based upon which it would be further ready for the future role of predicting the failure. The idea here is to see that the equipment is able to, that the predictive maintenance solution is able to predict the failure before any actual findings occur, so that an appropriate corrective action can be taken. So why we have selected 5 machines here in Uran? The reason is that the data is readily available with us. What were the key? Our process historian is capable of transferring the data to the predictive maintenance server via OPC protocol, which is an open protocol, and our system one is also capable enough to transfer the data through OPC, as well as our DCS historian is capable enough to transfer the data through to process historian. So the idea here is to have a centralized location of this system, which is well connected on an enterprise level, and we can extrapolate it to for future things also. So the key learnings associated with it is that probably we would be in a position to tell when the bearing is going to fail, and how much a machine can overrun for a more amount of period. And we can also argue with the OEM on the based upon the data that is available. It is a 5-year used case study. So what basically it is under O&M. This whole solution will be under O&M, and the idea here is to have the key learnings of one compressor can also be transferred to the another compressor. There would be this knowledge base which would be there in the system, so that all the past failures can also be recorded and documented in a presentable format for the future generations to come, or rather future new incumbent who is coming to the system. This is how we are doing the challenge. It can also be integrated to the SAP system, so that if there is any equipment failure history is recorded in our SAP system or our CMMS system, that can also be very well documented. It will work upon the FMEA guidelines, fault management, FEMA guidelines. Also, it will work upon this reliability center management, which is the key to the predictive maintenance system. The idea here is to have a system in place which can tell you about the failure beforehand. It works upon the principle of anomaly detection. So suppose there is a deviation from the operating limits and it keeps on increasing over a period of time, then it will give you an alert. So that can be interpreted in a much better way rather than the naked eyes. If you get an alert message, then uh, at least you are supposed to have this thing in mind that there would be something to show upon. Based upon this, we have developed this. This project is still under tendering in Uran, so we can share the outcomes once it is fully live. So the machines that we have selected in Urans are having all the data available with the 3500 system, and the process data is already available in the DCS. So that's how the thing is. So depending, let's see like how these things can be extrapolated further. This is how our idea of working is. It can be again based upon the data analytics. So dashboard is also being developed, and even we can have the alerts feature on our mobiles also. That is also something we have written in our tender. Let's see what we can get, and it can be further extrapolated to other assets and other critical equipment based upon the availability of the data, as well as the criticality and availability, and based upon the past failure history. So these three things can be kept in mind while deciding the machines. So idea is to have all these data going into one common wireless gateway, and then from that wireless gateway we can extrapolate it to our this predictive maintenance server, or directly to our historization server, which is OPC enabled. So this is a very good use case which can be extrapolated to other assets as well as other offshore location, where this centralized system is not available. This can be thought of. Since it is a one-way communication, so it is all cyber security proof. It is invulnerable to cyber security. So that dashboard would be sitting on the L4 layer, so that even the key stakeholders can also gain an insight and predict what are all those things is there.